Hey, it's Steve. Well, I recently put together an animation of Jupiter using data collected from my C6 telescope with my Canon SL2 camera, and in this video I'm going to show you how I did that. So first off, here's a sample of what the raw data looked like through the C6 with the Canon SL2 DSLR camera. I did use a 2x and a 1.6x Barlow in front of the camera, and I also used a 3x digital zoom on the camera itself to produce this particular video you're seeing here. So here's an example of what these clips look like, and to produce the animation what I had to do was do a series of these clips, take each of these clips, take the frames, stack them into a single image, do some sharpening on it, and then with each of those images that were created, basically put all those together to create the animation. So overall, a relatively straightforward process, but just had to be repeated multiple times, and so it did get kind of tedious, but it was something that was fairly doable with my simple setup that I have. So this is what I'm using. Again, it's a Celestron C6 telescope, and I'm using a Explore Scientific Twilight 1 mount. It's a simple Alt-Az mount. There is no motor drive or anything else on there. It's just a simple, you point it where you want to take video, and then you have to use the manual controls, or just by moving the telescope itself, track the object you're trying to track. And so you can see here what everything looked like during the night that I was actually doing the recording, and you can see here a shot of how things looked on the actual camera itself while I was taking the video clips. So to produce the animation, I was doing a series of video clips every 5 minutes that were about 1 minute in length, and then I took that 1 minute video to produce the single stacked images that were then compiled to produce the animation. So anyway, let's take a look at how I processed this video data to produce the images that were used to create the animation of Jupiter. Okay, so I'm going to run through how I process one of these video files coming off my Canon SL2 through my C6. And one thing to sort of keep in mind up front here is if you are going to work on making an animation from a series of images of Jupiter or whatever planet, you need to make sure you process them essentially all exactly the same, so you don't have a lot of weird variation from frame to frame. So obviously they have to be the same size. You want to keep the same type of color correction from frame to frame, things like that. And you really want to try to do everything as similar as possible, so you don't see a lot of frame to frame variation that really looks bad when you're trying to make a single set of video that I took. So I actually took about 16 or 17 video clips, again about 5-minute intervals per each one. And for the most part, I threw out 3 or 4 of them. I think I ended up with 13 final ones. The other ones just weren't good for whatever reason. There was just overall bad seeing at that time, and it didn't work out good for those clips. So and that's just going to be the way it is. As I'm taking 1 minute clips every 5 minutes, and sometimes you just have really bad seeing during that minute of time, and everything's just really turbulent, everything looks really bad, and you just can't make a good image out of it. And that's just the way it is. And so that's one reason why it's going to take a lot of series of videos if you are going to try to do just a single image, because you don't know when that best seeing is going to happen, and so it's going to vary over time, vary on a minute-to-minute basis. And so having a lot of video to go with works really nicely for trying to get that best image. So to start off here, I use PIPP. I use PIPP to basically, so I'm not using a tracking mount, so that's one advantage here. This software will actually go through and center the video that you're working on, and it will also crop it, which makes it a lot faster to work with as you go farther on the process. So I'm going to select this video file here that I'm going to work with here, and so just use the add image file here, and then I'll kind of just minimize that. I want to select planetary, because again I'm using a planet here. In this case, if you're doing a moon or something, the moon or the sun, you would do one of these other selections, or like the ISS or whatever. So anyway, just doing the select planet there, and for the most part you can leave everything more or less the same otherwise with the defaults. So now the cropping thing here is a big thing. I like to crop this, I think, to do 800 by 600. This is going to totally vary on your video, depending on how big it is and how much you want to zoom in. You don't want to have a lot of extra black space if you can avoid it, because it's going to make it a lot faster to process the videos. But I was also trying to capture some of the moons as well, and so that's why I have a little bit bigger of a crop than what I really need. And so you can go through here, make sure it's object planetary, make sure you have object detection located here, so it will reject any frames that don't have the planet in there, and that it can't fit it in that crop that you want to have. And so that's kind of the key thing there. And then quality, I just pretty much leave everything as a default there. Output options, it has to be AVI for this point in time here. And then the processing, now it's going to show stuff that's done, so you have to make sure you actually hit the start processing button here, otherwise you're just not going to have anything happen. So it's going to go through here and process all the video and make it, basically take the MP4, make it an AVI, and we'll look at the output here in a minute. But I'm running this on a 12-inch MacBook. So this is a 3-year-old MacBook. It's a 12-inch one. It's it's like a 1.4 gigahertz processor. Or even 1.3. It's really low, and so it does take a while on here. This is not an ideal machine at all for doing astrophotography work, but it works. I mean, it just takes a little while, and so a faster computer would obviously make this process a little nicer. But this is what I'm currently using. So we'll wait here for another minute or so, and then everything should be wrapped up for this process part. Okay, and that's just about done now. So once that's done, we can go ahead and close this. And then we're going to go to Autostakkert, which is sort of phase 2 here. And I'll get that opened up here. And then we're going to select the video file that we just made. So go to Open. I'm going to go to my folder here. And it's under this PIPP folder that got made. And this is the MVI file that was from the camera. Then that just puts the _pip.avi on there. And so we'll open that up, and then you're going to see here, and this is what PIPP does, which is really cool. So it basically makes this file here, and in every single frame, Jupiter is in the middle. And so that makes it really convenient, especially when you're working on, again, we're trying to make a video animation here, and so you want to have the planet in the exact same spot every single frame. You don't have to worry about trying to move it if you can avoid it later on. But anyway, you can kind of scroll through here and you can see what each of these frames look like. And so you can see some of them weren't very good, some were pretty nice, but that's pretty much what everything looked like. And so we'll go through, hit the Analyze button first as a way to start off. And that's going to take your video, and you're going to get this quality graph here. And this is kind of a key thing to look at, this green line here, to see where the quality just like plummets and goes in the tank. And it'll actually reorder this video too, so it'll be sort of an order of like good to bad in terms of the frame. So if you kind of scroll through here on the right, you can see everything basically just at the end it's really, really bad. And then, most of it's actually pretty good. It was a pretty good night of seeing, so most of the frames are good. As I scroll through here, you'll see the quality percent and the frame percent. And so that's kind of what we want to look at. So you can see, 80%, we're still at really high quality. I could have used more frames, but I'm trying to do this equally for all the frames that I'm creating, and so I went with 80%. So there's a little bit, some of the video clips are going to have more bad frames than others, and so forth. But anyway, so use 80% here. Also using a 1.5x drizzle, that's going to enlarge the image from 800 by 600 to 1200 by 900. So it'll be a bigger image to work with at the end, which is kind of nice. Especially if you're going to be trying to be playing it back at 1080p or something. It won't be you won't be stretching it quite as much at the end, so that kind of is nice there. And also you can use that to then downscale it again, which can actually make your image look nicer too. So if you do all the processing it on a larger image and then you downscale it later to a smaller image again, it does tend to make the final image look a little nicer as well. But anyway, so once that is done, in terms of your selecting the 80%, you need to go through here and place your grid. In this case, I'm using the 48. This is the size, and so you can see what that looks like. If you do 24, it makes a lot of smaller grid points. You don't really need that. This is for aligning the grids, or aligning the images to stack them, and so you don't really need that many points on something this big. Now, obviously, if it was a smaller image, you would want to use 24, or even a smaller number. But that's just the size of these boxes in pixels or whatever. So that's kind of what I'm using here is 48. And you can manually select them as well, which can help if you have like certain features you're trying to focus on, whether it be on Mars or the moon or whatever. Like maybe you're trying to get a crater or something like that. You might just pick points on that crater to make sure that particular crater is really what's driving how everything is being focused and stacked. So anyway, once that is aligned, or once those points are selected, hit the stack button. This will take a while on this computer because it's pretty slow, but it'll chug through here. So it's going through, doing all the alignment, and then it's going to go through and actually stack all the images here, and that's what's going to take the longest time here. But so what you're trying to do with Autostakkert here, and the whole point of stacking images, is that you can look at this one particular frame that you sort of see here on the screen, and you know, you can see detail, but it's all grainy, it doesn't look very good. And so by stacking a lot of frames together, one on top of the other, you basically get rid of a lot of that noise. And you also, for the most part, tend to, you know, kind of cancel out a lot of that turbulence that you sort of see from moment to moment. So, you know, all those sort of waves and sort of wiggles, you know, that the atmosphere is producing in the image tend to more or less cancel out. You're going to have some that, you know, where the image kind of wobbles one way, and other frames where it wobbles the other way. And so if you stack a whole bunch of frames together, a lot of that cancels out. Now, the process of stacking will also, you know, kind of create a sort of more blurry image because of that process, but you're going to have a lot of detail in there, and so when we do some post-processing and sharpening, you're going to really see a really nice final image, at least compared to what you're seeing in these raw images. So that really makes a big difference, and so the big thing there is that you have to get rid of the noise from the camera by doing the stacking, so when you're sharpening the image, you're actually sharpening what's really there in terms of detail, and you're not just sharpening, you know, camera noise essentially. And so that, you know, with that raw photo there, you try to sharpen that, you're just not going to have anything that comes out looking very good at all. But by stacking everything, it really smooths everything out. You get a really nice smooth final image with all these, you know, the stack of 1,000, you know, frames or whatever it is. And so when you apply the sharpening to that, you can work on that actual smooth data, and you're not, you know, being influenced by the camera noise and that kind of thing. So now the stacking is just about done, and once that's wrapped up here, the rest of it will go pretty fast. The map combination here, and we are saving and should be done here in a second. There we go. Okay, so we'll close Autostakkert, and now what we're going to do is go into Registax, which we will use to do some sharpening. Okay, and we will open up, go ahead and find our image that was made from Autostakkert. So we're going to pick this one here, and you can see the little preview there, and we'll open that up here in Registax. This is the stacked image now, and so this was a again, combining thousands of frames, and so you can see it's kind of blurry, but if we'll kind of zoom out to show the full image there, but you know, you can see all the smooth detail now. Again, remember the original images was very noisy, and now we have an image that is not noisy at all. It's really smooth, and it does, you know, hint at a lot of the detail, but it's just kind of blurred out a little bit because we're stacking so many frames together. So I have this, so you want to go over here to wavelet, and that's really where the magic happens. This is kind of all kind of smoke and mirrors, but I have this one setting that works fairly well for most of my sharpening. It basically, you just want to sort of adjust your levels of denoise and sharpen, you know, on all these different 6 wavelets that is applied to the data. And you can see, boom, when that's done, it does really pop out the detail a lot more from what was there before. So that looks really nice. I'm going to go through here and adjust the histogram down a little bit, just to brighten up the moon slightly. And so that'll be a little bit more apparent when you're doing the animation that the moon's actually there, because it does kind of get pretty faint. So anyway, I'll go ahead and save the image, and we'll say working or something like that. And then we can close Registax. And now I will open up Pixelmator, go to our image that we exported from Registax, and we're going to do a few things here. Now, I don't have, okay, and there's our image. First, I'm going to go ahead and I'm just going to do some color adjustments. But basically, I kind of go to this point up in here on the curve, and I kind of just pull that down to about here, and that kind of, but basically you're increasing the contrast some, and it does make everything pop a little bit more, I think, if you do that. Now, the other thing I have to do here, because I'm doing this animation, now as Jupiter moves through the sky, the angle that you see it in the image is going to change, and so that's going to really impact the loop. So I want to have Jupiter be sort of level in every single image here. Now the other thing is, because of the telescope having the mirrors in there, the image is flipped over, and I want to change that as well. So I am going to flip vertical to correct for the mirror, and so that gets me, sort of right side up, I guess, if you want to call it that, on Jupiter. And then I need to adjust. Let me go ahead here and show the grid, and I need to basically just rotate this until it is vertical. And luckily Jupiter has a lot of bands, and so it's fairly straightforward to get this pretty much. I'm just lining up the grid lines here with the colored bands, and that looks about right. And so we'll go OK and hide the grid lines. Now I need to go through, now you can't tell this, but there's actually a little bit of a border here because of the way that everything gets stacked. It's not quite, like the edge here of the image that was rotated isn't exactly black. And so I'm just going to go through and cut all this, because that's not going to be a problem. Even if I just do this as a transparency kind of thing, it's going to cause a problem. You're going to have this line over here. So I have to go through, I'm just going to go through and delete those border areas. And then I'm just going to fill it in with black. And that's all we got to do. And so now I will save it still as a TIFF, so I retain more data. If you convert it to like a JPEG or PNG, you're going to lose data essentially. So you don't really want to do any compression, until the very end if you can avoid it. But basically, that's all you got to do. And so you have to basically just repeat this process for every single video clip. And so this took several minutes, obviously, and you have to do it for multiple frames. And if you're going to, I'll just go ahead and close this. But again, so I did this for one frame, and then I went through when I was creating this. And so I went ahead and did this for 13 frames. So you saw one of these that I just created, but I went through and basically did this 13 times, where I had to, adjust the, go through that process with PIPP and Autostakkert and Registax, and then made some adjustments to the colors and the alignment in Pixelmator, and then I basically ended up with 13 images that were pretty much aligned. So I could basically then put these back through PIPP to do the animation. So I'll show you that again. I'll show you that really quick here of how I do the animation. You can do that in PIPP as well, which is nice. And so I'll open PIPP back up. Now we're going to add the images that were created here. So I will select all these 13 frames that were created, just like I did this one here in the demonstration. Okay, so we'll add all these images in here. We'll close the preview. Join mode, we're going to do animation. We'll do GIF, because I can't do an AVI. Well, at least we won't be able to play it back for you here. And so frame rate, we don't want to do a 3 frame per second. That's going to be pretty bad. So we'll do 13. Loop frames repeatedly. And then we will do start processing. And doing the animated GIF is going to be a lower quality than doing the AVI or whatever else, because it's doing some compression as well, making it into the the GIF image there. And so we will, I guess it's open in Safari. And there's our final GIF. I forgot to have it go backwards and forwards in this case, but you can see here, it's again just animating it repeatedly here, which is pretty much all you got to do. So again, it's a pretty straightforward process. It's just a tedious process because you have to process every single image, every single set of video that you created. And so you're going to be spending, as long as you use the same settings, you can go through it pretty fast. So you might be looking at 15 or 20 minutes per clip that you have to process. And then, you're doing it maybe, in this case, 13 times. So it does add up quite a bit of time in terms of the overall time it takes to do the processing. But pretty straightforward process. You get a really nice final animation out of this. So anyway, that's just a quick tutorial of how I process my imagery for Jupiter. I'm still learning how to do this. I've only been working at this on and off for the last year or so. I've only done it about half a dozen times in terms of actual sets of data I've worked with. And so I get a little bit better every time. A lot of it is sort of artwork. It's not just how well you take the data with your camera. And there's improvements you can make on taking the data. There's improvements you can make on the processing, just in terms of how you tweak it, how many frames you stack, learning how to adjust the colors and the sharpening, and so you don't go overboard and that kind of thing. And there are some other things you can do in here that I didn't go over to help improve things a little bit further. You can do things to. I also have a software called Topaz Denoise that can help remove a little bit of the noise too if you have a little bit of that left over at the end. You can also use WinJupose or something like that, where you can stack multiple images like this, multiple frames, and it will sort of de-rotate them. So you can basically stack your images over time, where Jupyter's been rotating, but it'll basically combine the data. It'll combine those frames and to make it an even better final picture. So you can basically you collect even more data and get a better final image. So again, this is not as good as you can do with a 6-inch telescope, but it does show you that you can get a really nice image out of a 6-inch telescope. And an 8-inch or 10-inch or 12-inch is going to do a lot better, obviously. But you can still see a lot of really nice detail with a 6-inch telescope that costs less than $400. 6-inch Celestron C6. So pretty basic telescope, but it can do really nice results. And so again, if you have a DSLR camera, go ahead and try this out. You can do some pretty nice imagery. Some key tips though with the DSLR: you do want to keep the ISO fairly low if you can. I found that going over 400 tends to result in degraded final quality. You tend to blow out the highlights too much, and a lower ISO is going to help. A fairly fast shutter speed helps too. I'm only shooting 30 frames a second in this case at 1080p, and shooting a higher frame rate would be better. If you get a dedicated camera, you can do 120. Of course, even a regular DSLR can do that a lot of times now too. That's better quality, but the more frames the better, because you can then have more frames in a shorter amount of time. Now again, because Jupyter rotates really fast, you can't do a long video capture. If you try to record like 5 minutes of video and then process that to make one image, it's going to look bad because all the details have rotated so much within that 5-minute interval that everything kind of gets blurred out. You're not going to be able to sharpen that into a nice image. So you want to keep your images down to about a minute or less. You can maybe do 90 seconds at most, but really a minute or less is better for Jupyter because it's spinning so fast. And so the higher the frame rate, the more frames you capture within that 1 minute, and the better off your final picture will be. So that's kind of a key thing there. So I was doing a 1/60th of a second shutter speed, shooting at 30 frames a second, and I was using a 3x digital zoom. The digital zoom on the Canon works out. You get a better picture if you use a digital zoom than if you don't, because a 1080p video is not just cropped in the middle of the sensor. It's like the whole sensor, more or less, and it's the bulk of the sensor, and then they kind of like multiple pixels get assigned to each final pixel in the 1080p video. But you don't really want that. You want to really have something closer to 1-to-1 pixel ratio. So you're not kind of averaging pixels together to produce the final video, and then losing data that way. And so the digital zoom will actually, if you do the digital zoom, you can still get a 1080p video, but it's closer to being just that middle part of the sensor. So it's exactly that 1920 by 1080 set of pixels in the middle. You don't want to zoom to where you're cropping below 1080p in terms of the pixels, and because then that's going to really degrade your video really fast. So you can't go too far with that, but you want to get something close to being an actual crop of just the sensor, and you're not actually losing data, but you're actually getting something close to a 1-to-1 pixel mapping of reality to what the sensor is picking up. So that's kind of how I do the video. Again, I use a simple Alt-Az mount, no tracking, and it works really well. And because again, you're just taking video, you're not doing still images. So the Jupyter can move across the frame, and that's fine. And then PIPP's going to take all those images and recenter it, and everything is going to work fine for doing all your processing. So you don't need an expensive tracking mount to do planetary photography, which is really nice. You do for other deep sky photography, but not for planetary photography. And so it does, again, you can use a pretty simple setup. I'm using a $200 mount with a $400 telescope, and I already had a camera, so I didn't spend anything additional for that. And so it's a pretty simple setup for planetary photography that produces really nice results, and you can see what you can get here. So anyway, I encourage you to give it a try if you haven't done this before. and see what you can do with your setup you might already have. So anyway, that's all for now, and thanks for watching. Bye.